build's not quite like the B2, but similar. This engine building has a lot of engines running in it, but the one running the big belt for the woodworking equipment on the other side on their line shaft here is this Ruston, which is an English engine, so it's made a heck of a journey to get over here to Minnesota. This engine has the low tension magneto and ignition setup that is friction driven off of the flywheel, which is interesting. You'd set that up and rub it on the flywheel, and there's a little governor to keep the magneto running at the right speed, because low tension make and break relies on steady current through the igniter, and then when the igniter is separated inside the engine is what causes the spark to ignite. So it doesn't matter how, the magneto has to run at speed to create the current needed, but unlike high tension ignition, where you get the one spark you need when the magneto fires and have to have it timed to the engine, the magneto itself is just generating the small current used and constantly applied to the igniter inside the engine. This is a local engine nearby this show from about, an hour and a half away. The Keller, built in Bloomer. It's got a pump jack from Evansville, Wisconsin. The Gould's 3-cylinder single-acting water pump. And it's connected to a vertical cylinder inverted engine. So the head and ignition are on the bottom, and then the crank is on the top of this engine. Those were popular for a while because it did help keep oil down on the connecting rod. This is a Perkins pump engine from Perkins Windmill, and it's got a very unique governor and igniter link there. It's a low tension ignition, and the single vertical shaft has governor weights on the bottom for the lockout, and then that top double cam has the igniter lobe and the exhaust lobe on it. So that's a pretty interesting setup. It's also a dedicated pumping engine. It's connected permanently to the pump, or semi-permanently, and would require tools to remove. A lot of the semi-dedicated pumping engines had a way to remove the pump arms so that you could use them for other tasks if you didn't need to pump and wanted a source for other tasks. I've also been told this is an open crank engine on the bottom. It looks like a crankcase, but on that base underneath is completely empty, and so it's total loss lubrication again. This is a smaller Z than the Z1 model, but still a Fairbanks Morse Z, and a sharp looking engine. A couple of unique engines. The Aero motor with its fluted hopper here. And next to it is this lovely New Holland with only one flywheel on it. And then New Holland liked to put their magneto on the end. That's another interesting location for those. The cute little engine, the Woodpecker. unique hopper style that a lot of other engines didn't use. And then a row of Fuller & Johnson. This is a tiny Novo, and then a pair of vertical Novos. This engine has a lot of repair work on it. Clearly had a cracked hopper and some other damage, but it's running with those repairs. This Novo also has a cracked hopper that was repaired. That's what got a lot of these engines. If you left water in for the winter, it would freeze and crack the hopper. And then you'd have to decide whether you could manage a fix or if it was cracked into the cylinder and you couldn't get in to repair it. Red Wing Motor Company. This is the engine local to this show. Built in Red Wing, Minnesota. Just a little ways south of here. At the turn of the century, almost everybody had an engine company and a local foundry that would build engines. Another one of the local Red Wings. This is another converted steam engine. It's hot tube ignition. You can see the pump arm on the side of the cross slide there. This was done by Acme, so it's roughly 12 horsepower according to the tag, but would have been set up at a oil field or something and run on effectively free gas. So